Hi everyone, it's Tom Stevenson, and today we are going to look at the new change of value module. That's one of the new ion modules in the Virtual Ion Processor, or VIP, in the Power Monitoring Expert 8 release. Like the previous videos for email, alert, and database import, we'll quickly cover the fundamentals of the module and the overview and move into a couple of applications to get you started quickly. So the first question might be, what is change of value? What is this module? And essentially it's a convenience module. You can do what this module does today with existing modules in the VIP, but it results in larger VIPs, more complex VIPs. So this is simply just a merging of functionality to make something easier to do today. And change of value, if you're familiar with the building space, is really just about logging only when there is a change in state, whether that be a binary or an analog value. And this might be for equipment in terms of an on-off state or alarm, normal, okay, fault, enable, disable, and maybe in the case of a chiller, multiple states. And there's some reports coming later this year, another module that will start to take advantage of some of this data. And as you can imagine, if you were to start to look at your energy usage by hours of operation or percentage of time that equipment is in a given state, we start to get some valuable views on your energy data, and conditional upon the state of the equipment. How does it differ from a Setpoint module? Well, a Setpoint module will assess its input versus a user-defined threshold. And the subtle difference now between a Setpoint and change of value is that change of value is assessing its input versus a user-defined delta value, but it's always comparing to the last changed value. As a result of this, on the screen right now, you'll see two VIP subframeworks. The top one here that says binary state change needs two Setpoint modules to trigger a recording on a state change from 0 to 1 or 1 to 0. And that's again due to that, how the Setpoint module works and where you would see your trigger from 0 to 1, this alarm, and from 1 to 0, this alarm, pulse merge, and then record the value of my digital input or whatever it might be in this case. It gets a little bit more complicated for the analog case, as you need some Setpoint modules to cover each discrete state you want to trigger on, which is shown here, and the and/or module becomes involved as well, pulse merge, and then record the analog value. So if it goes from 0 to 1, 1 to 0, 1 to 2, 2 to 0, whatever the state changes might be, you need to make sure your Setpoints cover off those cases. So this is illustrating what I said before, is you can do it today with PME 7.2. It's just for convenience and simplicity and time savings, it's been made easier in PME 8. Let's take a look at a change of value module. For inputs, like a Setpoint, it has a source. So this would either be the binary or the numeric value that will be monitored for change. The enable input works like it does on every other ion module. A value of false will stop the operation of the module, and if it's unlinked, it's enabled. There's only one setup register, which is the delta value, so the amount the input needs to change by in order to detect a new change. The default is 0.5, which is essentially testing a binary value, like 0.5, if it goes from 0 to 1 or 1 to 0, will both produce a change. For the output registers, the first register is the last value register, which is updated with the new change value. So if the module detects a change, it'll update this last value register with the value that occurred, that was detected. Like a Setpoint module, there's also a trigger output, and this lets us trigger our recorder or potentially other functionality. And we don't really need to talk about the event register. It's there just for the purposes of the event records that will get reported. And that's covered in the IAN reference documentation. Let's do a little example together. If we take our binary case, let's link our external Boolean to the input. We'll keep the default value of 0.5 for the delta register. And in Vista, we'll look at the output, which is this last value register. It's not available right now because this framework is not online. I'll hit send and save, and you will notice that the value is now 0, so the first change was detected. And I have a switch linked to external Boolean 1 here in Vista. The last value is 0. If I change the switch to on, you will notice that it will detect a change. The last value output has been changed to 1. The trigger output would have been triggered. And similarly, again, when I change it back to 0, the last value changes to 0, and the trigger would have happened again. So in the case of this framework, we now have the ability to replace all this simply with one change of value module. And if we were recording, we can now link the last value to a source we want to record and the trigger to the record input, and we have a replacement framework. We will log a change to the database whenever this value has changed state. Let's move to the analog state change case now. And if we link our numeric value, and let's change the delta value to 1. So anytime we see a change by a step of 1 in any direction is when we want to detect our change. Back in Vista, let me just relink this one now to module 2. And now we're using this numeric control object. We've got our value of 0. Let's do a state change to 1. And as we saw with the Boolean input, we can see it detected that. If we change it to 1.5, it hasn't changed by a value of 1 from the last recorded value. We will see this change to 1.5, but of course no detected change. We could go to something quite close. And really, in the framework, this is likely not the values you would be receiving, but just to illustrate how the module is working, we go to 2, which is now the difference of 1 from the last change value, so you can see our last value updated. And similarly, if it went back to 0, that's more than 1, and we've detected that change. And this is where all this more complex logic comes in to detect all those state changes in the case of an analog value. Maybe it's the state of your chiller. So simplifying this framework becomes a lot easier now. We've got our change of value detection, and again, for our data recorder, we can take the last value as the source and the trigger as the record, and our VIP has just become simpler and smaller. I'm really interested to hear other applications that you may find for this module where you've been looking for change detection. The one that really does come to mind for me is, again, with the email module, which you may have watched in a previous video. You should go watch that one, it's good. But again, if you're interested in a change in equipment state, you could just trigger yourself an email using this module, pass the value into the email, and within the subject or message of your email, give yourself a message that says this piece of equipment has changed state. So that's another application that this module could be used for. And yeah, please do let us know other ones that you find some use for with this. Okay, I hope you enjoyed the video, and I hope it does jumpstart your use of this module. And as always, feedback's appreciated. Have a great day, everyone. Talk to you soon.